Okay, I wanted to do a few more truth tables to demonstrate again checking sentences as set no logic, some slightly more complex sentences to see whether they're truth functionally true or truth functionally false or truth functionally indeterminate. It's just good practice. Truth tables take practice, just like everything else in logic or math or life in general, I guess, all right? I went ahead and I made the truth table for us again. Remember, I built this just like I showed you. I started on the right and I alternated T's and F's. Then I moved one to the left and went with blocks of 2, and then one more to the left and went with blocks of 4. If I had to keep going because I had a larger truth table, I'd have to go to blocks of 8. A truth table can be as big as you need it to be. Although, obviously there's practical limitations on what you can do with them. And this time I made these horizontal lines to keep our rows straight. And that's a good idea with larger truth tables. So what's our main connective here? Our main connective is a disjunction. Notice this disjunction is a binary operator that's under the least number of parentheses. And on this one, we can kind of take a shortcut. Remember, a disjunction is true anywhere that one of the disjuncts is true. It only takes one. In our right disjunct here, it's just R. That's pretty easy to evaluate. So everywhere R is true, this whole thing is going to be true, right? So on every other line of the truth table, on the first, third, fifth, and seventh, we know that this whole formula is true. Let's move over to our left now and see if we can keep taking some shortcuts, okay? We can go ahead and evaluate this starting with the most operator with the least scope, or the operator with the smallest scope, which is going to be this conjunction here that only scopes over P and Q. So remember, a conjunction is true anywhere both conjuncts are true, and we only need to check this on the even numbered lines, because on the odd numbered lines we already know what's going on. We already know that the whole thing is true. So here P and Q are both true. It's true. Q is false here. It's false. Because P is false here, this conjunction's false, and it's definitely false here where both P and Q are false. So what does that tell us about this conjunction here? Well, this is its left conjunct. It can't be true here. Can't be true here. What about here? R is false, and R is the right conjunct. That makes this conjunction false. Here, R is false as well, so it's false here too. Okay, we don't really need this. We just had to evaluate this in order to tell us what was going on with this. But this negation scopes over this conjunction symbol as well. So remember, it's just going to flip. It's going to flip the value here. So we got T, 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 T. We're negating this false conjunction. In other words, we're saying that the false conjunction is not true, and that's going to be true. So what does that tell us? It tells us that this is true. This is so this disjunct's true, 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 because now we know our left disjunct is true, and this is a truth functionally true sentence, right? Let's check a different one. We're going to do a biconditional this time to kind of set us up for our next topic. Let's make these lines one more time. This one, unfortunately, is not going to be quite as easy. Okay, we might as well just go over here and start on the left. We're going to start with the connective with the least scope, the negation. It's just going to flip the value of the P. So we're going to get false, 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 false. Remember, we're just flipping the value of the P that the negation scopes over. Okay, now we're going to take a look at this conjunction here. For the conjunction, we need, well, first of all, we can go ahead and evaluate this disjunction here on every line where P is true. We already know that the disjunction is going to be true on those lines because one of the disjuncts is true. So we only need to check the conjunction on these 4 lines because we're really only checking the conjunction so we can use it to determine what's going on with this disjunction. Remember, do as little work as possible, or do as little work as you're comfortable doing. If you're not sure, it's better to do more than too little, right? Q and R are both true here. R is false here, so the conjunction's false. And Q is false on both of these lines. It's going to be false here. So that makes the disjunction true here because one disjunct's true. And it's going to be false on these 3 lines. Okay? So even though this is not our main operator of this formula, I think we should go ahead and circle this so we kind of know what we're looking at. We can go ahead and erase that later, all right? But it'll help us keep it straight from these two because this thing's getting kind of busy in here, right? Remember, our main conditional is this biconditional, the triple bar. So let's look over here on the right. Let's start by taking a look at P because we know everywhere P is the antecedent, and everywhere the antecedent's false, the conditional is going to be true. So the conditional is going to be true on these last 4 lines. We know that already, right? So we only need to check Q and R on these first 4, okay? It's true here. It's false here. It's false here, right, because Q's false. And here both Q and R are false, so it's false there. All right? So what's going on with our conditional here? Well, P is true, the antecedent's true here, and the consequent's true, so it's true here. And here P is true, but the consequent, P is true on all 3 of these lines, and the consequent is false on all 3. So it's false here, and false here. So we can go ahead and now we can compare the biconditional. Remember, triple bar or biconditional, it's true everywhere where you have the same truth value on both sides of it, right? So we want to compare these 2 truth values. They're the same here. They're the same here. Same here. 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 And here. All right. And this is our main connective, so let's go ahead and circle it. We want to scratch this out or erase it so we don't get confused by the fact that we circled both of these. And we can see that this is truth functionally true.